And again, for this last one, we're going to do all of this in the calculator. According to an article in American Heart Association's publication Circulation, 24% of patients who had been hospitalized for an acute myocardial infarction did not fill the cardiac medicine by the 7th day of being discharged. Seems like those people want to die. Suppose there are 12 people who have been hospitalized for an acute myocardial infarction. State the random variable. So it looks like we're interested in the number of these patients who are not going to fill their medication by the 7th day of being discharged. So there's X is the number who fail to fill their medication. Write the probability distribution. All right, so I can have up from 0 up to 12, right? So we're going to quit out of here. I'm going to make a list of numbers from 0 to 12. So we're going to go to list ops sequence x, x, 0, 12. And we're going to store this in list 1. So now I've got the numbers from 0 through 12 in list 1. And then I'm going to go to distribution. It's a binomial distribution. Number of trials is 12. The probability is 0.24. And again, we're not going to paste the x value. So then we're going to store this in list 2. And now if I go stat edit, and let's get rid of all this stuff here, clear that out and clear that out so you can see this a little better. So there is my probability distribution all the way down through 12. So I have the probability distribution. Draw a histogram. So again, we're going to go to stat plot. Plot number 1, we're going to do a histogram. Frequency, right? Frequency is list 2. My window is going to go from 0 to 13, and my probabilities probably don't need to go up to 0.5. Let's see. Yeah, so let's go window. Let's change this down to like 0.35, see what that looks like. Yeah, that's a little better. So now there's my, I'll make it so you can see that again. All right, that's a good looking graph. It looks much more mound-shaped, but it still has this long tail out and onto the right. So remember, as the number of trials times the probability gets larger, if n times p and n times q are both bigger than 10, then this distribution will become much more normally distributed. So, shape of the histogram. It's mound-shaped, but right-skewed. Find the mean. Stat calc 1var stats on list 1 and list 2. So the mean is 2.88. Find the variance. So that's going to be 1.479 squared. So we're going to go 1.479 squared. So that's 2.187. And find the standard deviation. Standard deviation was the 1.479. Hope that helped.